In this recording, I hope that you will figure out how to do multiply and divide of numbers that have powers of 10. And we're going to take two numbers this time. Here is our first number, and here is our second number. Okay, this is a number where the first one is a number where if we take and move the decimal, we're going to move it the power of 10, which in this case is 11, and we'll have 11 zeros after that 8. Now, that moves it to the right. The other exponent is moving it to the left. So that's moving it to the left minus 3. That minus 3 moves it to the left 3. So the decimal starts here and moves 3 to the left, which gives us 0.008. Okay, and that would be that number there on the right. Now I've erased my little green marks, and let's just work on the problem and see if we can figure out what's happening. Our first job is to separate this into two parts. We're going to use the regular number that follows all the rules that you're familiar with up to now. And then we have the power of 10. And we're going to deal with each of these separately. So we'll get started. We're going to just take the numbers that we're familiar with. This is going to be 3 times 8. That's this guy times this guy. And that's going to be 24. Now, the next thing we have to deal with is the powers of 10. So we have 10 to the 11th, and we have 10 to the minus 3. Now, we're going to add those because this is a multiply problem. In division, we're going to subtract them, but in multiplication, we're going to add them. Now, because we have a positive 11 and a negative 3, when we add those two numbers, the result is going to be 10 to the 8. Now, we have to put everything back together again. We're going to put this number together with this number, and that's how we're going to write our final answer. 24, which is this guy here, times our power of 10, which, when we were done, was 8. And now, we got to go to scientific notation. If we're going to scientific notation, we're going to have to go over and change that 24 to 2.4. When we do that, to keep from changing the number, we have to modify that exponent so that we get to the same place. The way this is written on the left side, this number will have 24, and then that exponent is going to move it 8 over to the right. That means it's going to be 24 with 8 zeros. Now, over here, we're going to do something different. We're going to have our power of 10. It's going to change, has to change, or the movement of the decimal to this point changes the value of the number, which is a no-no. So if you look over here where you see the same and the opposite, I'll explain the business of opposite first, because that's what we're going to do by moving this decimal to the left. See, the decimal moved from here over to here. And by doing that, we're moving to the left. Well, the exponent wants to move the decimal to the right. And to do that, we are moving opposite directions. That will up the value of that exponent by one number, and that will be 9. And so we have 2.4 times 10 to the 9. Now, if you'll recall what I just said about the value of this number here, this number is going to come out to 24 with 8 zeros. This 2.4 times 10 to the 9 will move the decimal 1 and then 8 more. Oh my gosh, what does that mean? Those two numbers are the same, which is what they have to be. So this guy will be the same number, the guy on the right, our final answer, is going to be the same number as the one that we have on the left. It just looks different because we've moved the decimal and we changed our power of 10. Now I want you to stop the video and think about that for a moment. Okay, we're going to move on. What I just described to you was the situation where the final answer comes out and it's not in scientific notation, and it is a situation where we have an opposite. Now, if the decimal had started to the left of the number 2, if the decimal actually started here, which it didn't, but let's say it did, and we're going to move the decimal over here, that's moving to the right. And if that had happened, that means that the exponent would have to go down because we would have already moved the decimal 1. And that is where we have the same situation. We move the decimal to get the scientific notation to the right, and the exponent is positive, which also moves the decimal to the right. So there you have it. I hope that makes sense to you. And we'll try another problem now. Okay, this second problem has us doing division, which is just a little bit different. But I'm going to break it into 2 parts again for you. And why don't you try doing the 2 parts on your own? Stop the video right now and see if you can do this problem on your own. And we'll come back as soon as you're ready to restart. Okay, you either took a break or you didn't. We're going to continue now. And let's look at the 2 numbers that we have to deal with first. See, just like with multiply, we're going to deal with those 2 numbers first. And the difference is that this time we have a divide in the middle. So I'm going to take 2 and divide it by 8, which is the normal thing that you would do if it were written 2 divided by 8. That's what that means. The 2's on the top and the 8's on the bottom. So now we're going to get a number. You can get out your calculator or work it by hand. Okay, as we do that, we come out with 0.25. That's our number. Now, the next thing we have to do is deal with our powers of 10. So we got this guy and this guy. Now here's the rule. 10 to the minus 5 is on top. 10 to the minus 19 is on the bottom. When we have division, we have to subtract exponents. And the one that we subtract is the guy that's on the bottom, which is this little dude. So as we do that, if we subtract a negative number, it becomes a positive number. Minus a minus is a plus. Okay, so you've learned that in your math class. And now we have a 10 to the minus 5 plus 19. The 19 because we did a minus of that number over there. So now when we add those 2 numbers together, we have essentially 19 minus 5. That becomes, as you would expect, 10 to the 14. Okay, now we get to put our numbers together. So we have our 0.25. I'm going to make that a different color for you. 0.25. And we're going to multiply the power of 10, just like we did with the multiplication thing in the last problem. So we have 10 to the 14. Now this time, we've got to move to the right, like I was talking about before. Now that we're moving to the right, and the power of 10 also takes it to the right, that power of 10 has to come down by the number of digits that we move that decimal to the right. In this case, we're just moving it 1 to the right. And so that's going to make that number turn out to be 2. This is scientific notation now. I'm making it into scientific notation. And it's 10 to the 13. So the 13, because we're going the same direction, and let's look back at those rules that I wrote earlier. same is down. Okay, so the number went down from 14, the exponent went down from 14 over here to 13 over here. That's the down. If I had moved the decimal the other direction, I would have to increase that 14 to 15. But in this case, we have our final answer right here. Okay, just to set this stuff with you, why don't you work out this problem on your own and see if you can do it. Remember that it's divide. So stop your tape right now, or stop your video, and go ahead and work it, and then come back. Okay, whether you stopped or didn't, I'm going to work this out now and show you quickly how it goes. We're going to deal with these two numbers first. This is a division, so we got 12 over 6, and that's going to be equal to 2. So that's the first part of our job. Now we're going to do the division of 10 to the 6th by 10 to the 3rd, minus third, that is. Now, if we got a minus third on the bottom, we have to change the sign, and our new exponent is going to be add instead of the, it's going to be add instead of subtracting as it would be if we were multiplying. So we change the sign of the 3, and then we add it to the 6, and that becomes 10 to the 9th. And now our number is going to be a combination of this and this multiplied by each other, even though this is a division problem, and we get 10 to the 9th. In this case, the decimal is right here, even though it's not written, and we're already in scientific notation, and this is a done deal. That's the answer. Okay? Okay, one more problem to set the concept with you. And again, this now is multiply, and as a multiplication problem, we're going to take, first of all, these two numbers, and we're going to multiply them by each other. So this is going to be 2 times 6. That's going to be equal to 12. And then the next thing we're going to do is multiplying of the exponent, or the powers of 10, that is. So we got 10 to the minus 8, and we're multiplying that. By the way, this is our partial answer. And we're going to be multiplying that by 10 to the minus 5. Now we add the exponents, so they keep the signs that they have. And so our exponent at the end here is going to be 10 to the minus 13. All right, now that's the other partial answer. And we're going to bring those guys together over here, and it's going to be 12 times 10 to the minus 13. Now, the decimal is going to have to move, and the decimal is doing this, going to right here. And so in scientific notation, so after we move the decimal, we have to make the number be the same. Now, I'm moving the decimal to the left, and the power of 10 is also going to the left. That means we're going the same way. So, if you think that that would reduce it, if you did, you're right. And the new power of 10 is 10 to the minus 12. And this, then, is our answer in scientific notation. This would be a correct answer, but it's not in scientific notation. I hope you got a lot out of this. If you need to watch it again, go back, and hopefully this will set it for you for multiplying and dividing powers of 10.